So, you guys have learned about how to write and name chemical formulas and how to find the gram formula mass. Now, let's do an application of gram formula mass known as percent composition by mass. Now, this is no different than finding the percent of anything. You just simply take the part and divide it by the whole and you multiply by 100. That's the way you've done it up to this point. There's a couple of ways you can find the percent by mass of elements in a compound. One way is doing it experimentally. So, for example, let's say we ask a substance for its name, and then we just sit and wait for it to answer. Well, we're going to wait for a very long time because compounds don't have mouths, they don't have brains, and they're not capable of understanding our speech or communicating with us in any way. Therefore, you're going to have to do some sort of active experiment to figure it out. So, step one is to decompose the compound. This can be done by either melting it and sticking electrodes into it and passing electricity through it and breaking it up that way, or you could add enough heat so that the substance just simply breaks apart into its elements. It depends on what the substance is. The positive metal ion will gain electrons back, turning it back into its pure metal element. The negative ion will become the pure nonmetallic element by being forced to give up the electrons that it gained to form an ion to begin with. Whichever way you choose to decompose it, you record the mass of each element that you've decomposed into, and then what you do is you take a little bit and you heat it up. And the flame spectroscopy will tell you how to which elements you actually have in your sample. Let's suppose we do this experiment. We find out that the metal element is potassium and the non-metal element is bromine. So let's find the percent by mass of the potassium and the bromine given some data. Let's say the substance weighs 83.2 grams, and we were able to decompose that into 27.7 grams of potassium and 55.5 grams of bromine. To find the percent by mass is very easy. You just take the mass of potassium and divide it by the mass of the sample times 100. And then for the bromine, you do the same thing. You take the mass of bromine divided by the mass of the total sample times 100. Notice that for both, we have the same denominator. It's part over whole times 100, part over whole times 100. And then 3 sig figs, 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 3 sig figs. So experimentally, that's how it can be done. And you may very well do an experiment in class where you find the percent by mass of elements in a compound. There is another way to do it, and that's by using the empirical formula of the compound. And in this case, instead of getting experimental data, you just use the atomic masses of the elements in the compound. So let's say potassium makes up 33.2% of the mass of a compound. Let's say we have a 100-gram sample. That would mean potassium's mass would be 33.2 grams, because percent means out of 100. Bromine would make up the rest, 66.8% of the mass of the compound. So if we're assuming that we have a 100-gram sample, bromine would weigh, what's 66.8% of 100? 66.8 grams. So this would be the mass of the part that is potassium, and this would be the mass of the part that's bromine. So what we would do is we would take, for potassium, its mass and divide it by potassium. Hello, what are you doing? And we divide it by the atomic mass of potassium, and this gives us the number of moles of potassium. To find the moles of bromine, we simply take the mass of bromine and we divide it by the formula mass of bromine, and that will give us the moles of bromine. And that gives us a mole ratio. To find the mole ratio, we just divide them both by whichever one is smaller, and we come out to a 1-to-1 ratio. So our formula is KBr. Now I'm going to be showing you in more detail how to do this in the next topic. But what we need to figure out first is, how do we find out the percent? So to find the percent, we use on reference table T on the back of your reference tables the percent by mass formula. Percent by mass is the mass of part divided by the mass of whole times 100. So to find the percent by mass of an element in a compound, you would simply take the formula mass of each element and divide it by the formula mass of the compound, part over whole, and you would multiply the resulting ratio by 100 to turn it into a percent. So here's how this looks. Let's get the percent by mass of the elements in calcium phosphate. Calcium has a mass of 40.1 for each of the calcium atoms. There are three. Sorry, my cat is sitting on my keyboard and advancing the keyboard. Let's go back here. Ah, there are three calciums, each weighing 40.1. Okay. There are two phosphoruses, each of them having a mass of 31.0. So we'll multiply that out and get 62.0. There are 4 times 2 is 8 oxygens. Each one is 16.0. And that comes out to 128.0. Now, these numbers would represent the part. Now let's divide by the whole. How would we get the whole? Well, we just simply add them up. So when you add up these numbers, the total comes out to 310.3. So we simply take calcium and we divide it by the total mass. We take phosphorus's mass and we divide it by the total mass. And we take oxygen's mass and we multiply by the total mass. And then we divide by the total mass, and then we multiply all of those numbers by 100. Now, as far as significant figures are concerned, you'll note that 4 sig figs, 4 sig figs, 4 sig figs. 3 sig figs, 4 sig figs, 3 sig figs. 4 sig figs, 4 sig figs, 4 sig figs. So once again, you take the total mass of each part and divide it by the total formula mass of the substance. Take that ratio and multiply by 100 to turn it into a percent. Now, there's another kind of substance we haven't looked at yet, and that's a crystal that has water trapped in the crystal lattice. There's a lot of empty space in a crystal lattice, so water might be trapped. Remember, water is a polar molecule, and having oppositely charged ends can attract very strongly to ions. So it's not unusual to find a crystal that has water, represented by blue, trapped in the spaces in between the ions. These are called interstitial spaces. So the water is represented by the blue dots. Now, how do you figure out how much water there is trapped in the hydrate? Well, first, you're going to have to get rid of the water and then measure the mass before and after getting rid of the water, and that'll tell you how much water there was. So, to find the percent by mass of water in the hydrate, and you will likely do a lab on this, you'll take the hydrate and you'll weigh it. I'd like you to notice the blue color because that will be important. Let's suppose the mass of the hydrate is exactly 3 grams to the nearest thousandth. You would not actually put the hydrate directly on the balance. You would place it into another container, such as an evaporating dish. Then what you'll do is you'll apply heat, and the heat, and again, that's why you want an evaporating dish, the water will leave the crystal. And as I do this, you'll notice the water molecules actually leaving the crystal, but I want you to notice the color of the hydrate as this proceeds. So we're going to add heat and the water will leave. It's still blue, still blue, still blue, but gradually it gets lighter and lighter and lighter until eventually, once all the water is gone, the color changes to a new color, in this case, just sort of a grayish color. This is a property of copper 2 nitrate hydrates. It turns from blue into sort of an ash gray color. If you had cobalt chloride, it would turn from pink to a blue color. So when you have a transition metal in your compound, there's going to be a color change when you remove the water from the crystal lattice. Anyway, by adding the heat, there's no longer water in the crystal. So we're going to re-weigh the crystal. This time, since it has no water in it, it's called an anhydride, and you'll note that the mass decreased. The difference between our starting mass and our ending mass is the mass of the water you drove off. So the percent by mass will be the mass of the water divided by the mass of the compound. So we'll take the difference between the two masses to find the mass of the water. And then we're going to divide that mass. That's going to be the mass of the water. And we're going to divide it by the mass of the original hydrate because the water was part of this original 3-gram sample. So we'll take that part, divide it by that whole, multiply by 100, and that will give us the percent by mass in the hydrate. And it's different for every hydrated substance because the amount of water that can be trapped in the crystal lattice can vary because those interspatial spaces are differently sized and the attractions are different and so on. You can also find the percent by mass of water in a hydrate by using its formula. What is the percent of mass by water in cobalt 2 chloride hexahydrate? Well, first you would need to write the formula for cobalt 2 chloride. Cobalt 2 is CO plus 2, chloride is Cl minus 1, so you would drop and swap and get CoCl2. Hexahydrate means that there are 6 water molecules trapped for every formula unit of cobalt 2 chloride, or 6 moles of water trapped for every mole of cobalt 2 chloride. So this is the formula of the hydrate. We're going to put a large dot in between the crystal and the water that's trapped in it. There is a 1 to 6 molar ratio of crystal to water. So how do we find out the percent by mass? Well, we find the formula mass of water. Each hydrogen is 1. 2 of them will be 2. Oxygen is 16. So each water will have a mass of 18.0 grams per mole. And there are 6 of them in this formula for a total mass of 108.0 grams for just the part that's water. We're going to have to add that to the mass of 1 cobalt and 2 chlorides. So let's go ahead and do that. Cobalt is 58.9. Each chlorine is 35.5 for a total of 71. The 6 waters is 108.0, meaning the entire gram formula mass is 237.9, of which the water makes up 108.0. So we're going to take our part, we're going to divide it by our whole, and multiply it by 100, and that will give us the percent by mass of water in the hydrate. Four significant figures. 4 significant figures leaves us with 4 significant figures in our final answer. And that's how you would find the percent by mass of water in a hydrate. So regardless of how you're doing it, percent by mass is simply the mass of the part divided by the mass of the whole times 100. Now, that is going to be all for this section. In the next topic, you're going to learn how to do the thing I showed you at the very beginning and calculate the empirical formula. So practice these, and I'll see you next time. And until then, bye.